Hey everyone, welcome back to another Tashi live stream. I'm Ken Anderson, CTO of Tashi. I want to remind everybody that we do this stream every Tuesday at noon Pacific. You can follow us on YouTube, on LinkedIn, or on X. Make sure you set your alarms. Uh, I don't know that all of the different protocols are as good at reminding you of when our streams are going to be live. YouTube's pretty good about it. I know on X, as opposed to say like doing a space, you just have to click on the link at the time we start the broadcast. So I encourage you to set your alarms, follow us so you get notifications and all the upcoming topics. As you know, every week we just pick a new topic in the gaming space and we invite a guest. This week, we're especially grateful to have Kenny Swayze with us from Satoshi's Palace. So I'm going to bring Kenny on now. Kenny, thanks for joining me today.
Hi, thanks for having me. It's great to be here.
Yeah, so tell me a little bit about Satoshi's Palace. I've been playing around with it for the last 24 hours, getting familiar with it. And I obviously have a bunch of questions and thoughts, but why don't you give us a quick overview of what the project is, what network are you built on, what technologies are you using, and what's kind of the motivation behind the project?
Yep. So, we're Satoshi's Palace, and essentially what we're trying to build here is a online peer-to-peer blockchain-based or crypto-based gaming platform where people from all over the world can come on and trustlessly play games like our first game we launched 2 to 3 weeks ago was we call it Bull or Bear. And kind of the idea here is, it's Bitcoin price predictions in the next 5 minutes. So, you might have to go. You think about playing Earth, kind of playing the stock game of trading stocks, buying options, betting up and down. There's kind of a big learning curve with buying options, and it's kind of confusing. You have to understand what puts are and calls are, and there's this whole complex process. But it's a fun game that I personally enjoyed, and we really just wanted to take a lot of that fun aspect and make it all the fun without all of the complication here. So we can do, yeah, you have it on screen here, is you can just bet up or down. Do you think Bitcoin price is going to go up or down in the next 5 minutes? And then you basically place your bet. This is built on Secret Network, which is, a great chain for lots of different gaming reasons. And yeah, what we're really trying to do is just make it easier for people to play and have fun in the crypto community without having all this learning curve stuff.
Yeah, and I noticed you have Bull or Bear is your mainnet app. You've got a few testnet apps
Hmm.
as well. I
Yep.
was going through some of these. You got your predictions market. Also
Yep.
looks like
This
a lot of
is,
fun.
yeah, this is coming soon. So this is, you've seen things like Polymarket, perhaps, which are a
Mhm.
prediction market where you can go place a bet on some outcome of sports games. Is a very common thing. MLB, NFL, and we plan to support all of those with our Oracle. This is something that's coming out in probably want to be our next top game here because we've gotten a lot of feedback that this is something that people want. Yeah, I mean, you can place a. This is testnet, right? Try to hit
Yep.
that connect wallet. There might be an easy testnet wallet for you. Oh no, I think we disabled this, so
Okay.
no, don't worry about it.
All right.
Yeah, if you click into here, you could actually go place a bet, assuming you had a Kepler wallet all set up and funds ready to go on testnet. You can go in here, and do you think that Miami is going to win, or you think Arizona is going to win? And you just place on how much money you want to bet, and it's pool style betting.
Yep.
So when another person might take the other side of the bet, and they think Arizona is going to win, and since it's pool style, it allows uh, tons of different people from all over to come in and provide the liquidity. So that these numbers can get kind of ridiculous if Arizona. If I don't know too much about whatever sports ball this is, MLB, but if this is an insanely skewed matchup, Miami is just going to dog. These odds end up going to be like 6x if you're going to bet on the underdog like Arizona, and that would be kind of the idea here.
That's I mean, that's what it is. Those are what prediction markets are doing, but it looks like it feels like it's a little more gamified than a lot of other products.
Yeah, we certainly like the idea of gaming, and we were essentially gamers to start when we started just messing around in crypto because I think Coinbase does a lot of marketing to gamers, and that gets a lot of very interesting people brought into the crypto ecosystem, and there's a high correlation between devs and gamers who want to play games, and It's lots of interesting development problems to solve when you're making a bunch of games, and that's a lot of fun.
Well, and I
Yep.
think one of the cool things about the gaming space in general, and here we're kind of using gaming in two words, right? There's like the legal term of gaming, and in
Mhm.
certain states in the US, the legal term of gaming is quite literally like gambling,
Yeah, that
is how would they
is the
define it?
legal term. We're trying to use it more in the fun term, but there's also, uh, gambling is a correlated term that goes on with in line with the legal gaming term.
Right.
And that's where the slots would fall under. This is something that's future plans to come out, but does obviously fall into that different legal jurisdiction.
Yep. Yep. How do you guys navigate all of that? Just out of curiosity.
Well, at the moment, we just don't have games that are gonna cause legal problems for us. Like slots obviously might have some legal things to deal with, and those are future problems that we don't deal with yet.
Yeah,
At
and
the
it's on
moment, we're just
testnet,
working
right?
on.
So we're not talking about real money
Yeah,
here
this
on
is
the testnet
this is
side. So
testnet at this point, proof of
yeah,
concept that we can run this type of thing eventually. But Bull or
yeah,
Bear, that's trading effectively, so a skill based game.
that's right. That's right. Very cool. So you're able to kind of, yeah, it feels like we're definitely on the side of gaming, which is, I don't want to call it like the play to earn. I know there's a play to earn category, which is like the more you play, the more you earn.
Mhm. More
This
like
is
win
more
to
like,
earn is is the
what's
accurate
that?
term. Win to earn, you have to win.
That's right.
Yeah.
That's right. Yeah, win to earn, but it's the gaming side of win to earn.
Yep.
And you guys are using the secret network, correct? That's all built on, if I remember correctly, that's all built on like the Cosmos SDK, right?
That's a Cosmos ecosystem blockchain where kind of their big selling point is that one, they have confidential computing, and that
Hmm.
lets us, from a gaming perspective, that lets us do some really interesting things. So if you think of really big, interesting games like League of Legends or Counter
Hmm.
Strike, there's some concept of a fog of war where
Right.
one team knows something that the other team doesn't, and that's something that's only possible if we have a blockchain like Secret Network where we can actually have confidential state. And that really just opens up a lot of doors in gaming. 'Cause, effectively, if we're to think of, say a game of poker, if we're to play a game of poker on a
Right.
public blockchain like Ethereum, it's going to be really hard for me to bluff when my opponent can go ahead and look up what my hand is on the
That's right.
blockchain. That's really not going to be very effective.
Yeah, and I mean, just in gaming in general, that's a challenge, right? So there is this talk of like synchronized state versus like predictive or what they call deterministic lockstep. So
Hmm.
in deterministic lockstep gaming, which is basically what Tashi enables for the game architecture and design,
Gotcha.
the idea is that every machine knows everything about the game state, and with Tashi, our primary objective is to synchronize that state to ensure that everybody has the same state and everybody's acting on the same state. That's primarily our function. But then in state sync style of development, you have a server
Hmm.
that knows everything, and you as the client only know a small subsection of that greater picture. So I think a lot of the games that are building on blockchain right now, if you're building with smart contracts, anybody can go look at an explorer and kind of
Yep.
unwind the execution functions and the state of the game and the variables that are storing state, and they can look and see what's the current state, and they can write bots that unwind that and make decisions in the game. But
Yep.
what you're saying is
Exactly.
because of the secret network, and if I remember correctly, they're using like a trusted execution environment, correct?
Yep. It's a hardware based
Yep.
confidential security here. So that there's a special type of Intel processor
Hmm.
that no one can look inside of because they made it really well, effectively. And it's called a TEE, which allows Secret Network to offer confidential computing.
Yeah, that trusted execution environment on Intel, and I'm trying to remember what's the name of the SGX. I think was the Intel's version of it
I
because I know
believe
AMD
so. I
has.
believe that's it. Yeah.
Yeah, I think AMD has Trust Zone. I think was their version. But on in SGX, the idea is that there's a part of your hardware that can only be executed on with particular cryptographic methods, and you create
Yes.
like a pipeline between different machines, and they can share that space, the session they can share together, and they can pass commands back and forth and compute privately between each other and trustworthy. You can pass proofs back and forth that the execution was done correctly, or you can share like the actual items in memory or in processing between the two machines. But if you're outside of that session, you can't see anything that's going on inside that session.
Yep. I mean, like kind of the technical overview is it's the ultimate black box. You can't see
Right.
how it's executing on the inside, but you can give it inputs and get outputs. That's all you can do.
Right, right, right. And so, so Secret's taken advantage of that SGX technology on top of the Cosmos SDK, correct?
Yep. Yeah. So they basically implement the Cosmos SDK, but only let you run it on like an Intel SGX processor.
Okay, perfect. Now, how does the network get built? Are those a bunch of like proprietary hardware out there, or is it a fully public network where anybody who has SGX can participate as a node?
Yep. Yeah, it's decentralized in the manner that if you, as long as you have and can verify that you have that processor, that
Hmm.
trusted execution environment processor, then you're allowed in. But there is a verification process that I'm not super versed in the details of how it works, but a TEE can verify that it is a TEE.
Right. Yeah, absolutely. So and I was just trying to remember the term, but what they call sessions in SGX is called an enclave. So you've got
Yes.
your enclave
Yep.
execution where you can have a shared enclave with multiple parties and they can kind of compute things together and nobody outside of that enclave can see what's going on inside. So in this case, what you guys are basically doing is you're running the smart contract inside the enclave and all of the players are outside the enclave. Is that how that works?
Exactly. You got
Okay.
it on the nose there. And another thing that Secret Network is kind of huge about is because they have this secure enclave that no one can
Mhm.
see the inside state of, you can have on-chain verifiable random effectively because,
Yeah.
typically it's very hard to make random on a public blockchain because your seed's going to be public. But
Right.
Secret Network, that seed can be private, which means we can generate randomness very, very seamlessly.
Yeah, we actually had a similar challenge in the gaming space. So with the DAG, the consensus algorithm that we built, every transaction, so we're having, you know, millions of transactions a second, 30 milliseconds of latency, but every transaction is going to have kind of its signature and you can hash that signature and come up with a pseudo random number or pseudo random hash from the last transaction that took place on that network, on that DAG. And so that's how we've been able to kind of deterministically do it. It's kind of one of these
Mhm.
things where you just look at the latest transaction, you calculate that randomness, and then you apply it into your game. And it's deterministically the same for everybody and instantaneous because everybody's calculating that on their local machine. So I know we
Gotcha.
solved it a slightly different way, but the way that we solved it was just by having a signature that's unpredictable and having it happen very quickly so that you just don't have time to even try to guess what it's going to be, even if you could, but you can't because everybody can act on what was historically revealed, but they can't really act on what hasn't been revealed yet,
Gotcha.
as
So are
opposed
you
to
saying
secure.
that, at time of needing random, you look at the last transaction? Is that how it
Yep.
works? And then that last transaction, in theory, you can't control.
Correct. Yeah. So you look at the transactions. So it's just a stream of transactions, just like a blockchain. We'd have a stream of
Mhm.
transactions, but each transaction has its signature, right? So it's based
Yep.
off of the hashes of previous transactions. And in our DAG, we specifically have lots of transactions that are pointing to lots of transactions that each have their own hashes. So you're not really sure what the new hash of the new transaction is going to be until it's been finalized through the consensus process. And once that's happened, everybody knows what that new signature is and can hash that and use that hash as random immediately. So as soon as you calculate it, you can use that. Now the trick is how do you coordinate that? So what you might do
Yeah.
in our case, we might say, hey, we need a random number in 5 ticks. So whatever the hash is of the transaction in 5 ticks is. So in gaming, you usually talk in ticks. Um,
Mhm.
whatever that signature is in 5 ticks, use that as the random for the next function that gets executed. For example, if there needs to be some type of calculation of, you know, enemy spawning or world generation or whatever the case needs
Mhm.
to be. So so that's how we've done
Gotcha.
it because we're just using, I mean, we're already using cryptography. We might as well use the cryptography to create pseudo random. Now it's not truly random. Very few things in computer science are truly random.
Yeah.
Uh,
Truly random is a myth.
but even like cryptographically secure
Mhm.
pseudo
Yeah. If you
random
read all the
is hard
papers,
to
it'll
get to.
always say it's a pseudo random number that
Right.
is not, it's highly unpredictable, but it's a pseudo random number.
That's right. Well, and you got RNG, you got PRNG, the pseudo random number
Yep.
generator, and then you've got the PRNG, which is the cryptographically secure pseudo random number.
Yeah, but it's still a pseudo random.
That's
It'll
right.
it'll always say pseudo random.
And
Even when
unless
we're
we're
talking
talking
about
about
yeah, even if we're talking about
radiation,
verifiable random, it's still pseudo random. That
that's right.
yeah.
Yep. Everything we're doing is pseudo random, and I'm okay. I mean, there are different levels of random and pseudo random, and cryptographically secure. They get more and more secure and trustworthy over time as you
Yeah.
increase that compute requirement, um,
Yeah.
which I'm
I
fine with.
wish there was a way to make that sound because it doesn't sound great when you say pseudo random to someone who's not computer science versed, but
Right.
it is secure. It just has yeah, it's like how iPhones are water resistant
Yep.
and not proof. That's that's the that's the way it needs to be received.
Yeah. Yeah. Well, and I think it depends on who you're talking to. Like most computer scientists, most software engineers are going to be pretty pedantic about that word.
Yep.
Uh, you can say RNG, and they're going to go, well, technically it's
Yeah.
PRMG.
Yep.
But we all know what we mean when we say RNG. We're just talking about the random generator of whatever software you're working in. So, and everybody's going to have their opinion about where that randomness needs to come from and how you develop the seed for that randomness. So, anyway, that's one of the beautiful things of SGX is, I guess, to your point is, there is a seed in the enclave. There is a calculation that happens in the enclave, but unless you are in the enclave, you don't get to see any of that. So all you're
Yep.
doing is passing inputs into it and then receiving the outputs post calculation with something that's verifiable to say that, like, yes, this result came from this calculation.
Yes, exactly.
So, and I think that's one of the beautiful things about what SGX has done, and even Trust Zone in the AMD side, is that they've made it possible to kind of do what we're doing with ZK a little bit. I've thought a lot about how we use some of these trusted execution environments as opposed to
Hmm.
ZK, but I think the thing with zero knowledge proofs is that it can be calculated on anything. While like
Yep.
enclaves and SGX
Yeah,
has to
there's
be
a
on an
big
SGX
advantage there for
compatible chip.
sure. Yeah.
Yeah. So cool. So tell me a little bit about. I noticed that you have documentation, and in your documentation, you have a developer docs. Is that so that people can leverage your gaming from their own applications? Like, is the idea that they're building over the top
Yeah, exactly. So
applications?
the idea here is, we're pretty in-depth software developers, and we made
Mhm.
for our own purposes internally this SDK that we can use for our front end to interact with our smart contracts. And it's super useful internally, but then we were like, hey, I mean, if someone wanted to build a trading bot to play bull or bear, they could just use this. And we love the developer community, and we want to open source things so that other people can use them. And yeah, it's super useful if you wanted to play uh, bull or bear programmatically, and you had a trading
Mhm.
strategy that you'd implemented, and you knew would work every if you had some real alpha that you could action on, you could build a
Yep.
trading strategy out of it.
So is your business model about building games that people can play on your platform, or is it more about building logic that encapsulates the game logic and exposing that to game developers to kind of like build their UI and their communities around?
Yep. Well,
Or
essentially, if you're
yes.
going to use our SDK, you're also using our smart contracts,
Right.
and that allows us to basically have this business model where we can take a small fee. At the moment, we have a 0% fee on Buller Bear, but
Mhm.
Buller Bear in the future can take a fee when we deem it's an appropriate community to do so. But at the moment, we're trying to just incentivize people to come and have fun.
Awesome. So, but you guys are going to be, I guess my point is like, there's a game experience component here from development
Yep.
perspective, right? So you can
Yes.
be a game developer, or you can be a technology developer, or you can be both. And like game developers tend to be really good at building games. Like they
Yeah.
understand the proper gamer experience for building games. They understand the technology and kind of like the animations that come with it. Us as as developers, so as technology developers, we tend to put out what we call like programmer art. It's like good enough for programmers, but it's not going to really, tickle the fancy of the
Yeah.
general game player. Are you guys kind of going both directions? Are you going to be game developers in addition to the technology developers? Or are you guys looking, is that the point of building the SDK, is to attract game developers to come build
Yep.
sexy mobile apps on top of
So
your platform?
yeah, so I mean, we build the game logic and the smart contract for ourselves,
Mhm,
so that we can run a business with it, and then we publish these SDKs so that other people can come along. And let's say we get, we would love to attract developers around Satoshi's Palace that can help us build. And the best way to do that is to actually open source things and let them come
mhm.
and bring them in when we think they have something to offer. And if we find someone that builds a nice front end for it, we'll say, hey, yeah, you should come work with us, and we'll get you in.
So you're thinking more of like you're using this as almost like a loss leader to bring in that game developer talent and then to help make the Satoshi's Palace like the premier experience.
Yep, yeah, we're very big into open source software and
Mhm.
getting devs to surround our community. That's going to be huge for us.
So how far are you into this journey?
Let's see. Well, we launched our first game. We had launched many testnet games
Mhm,
up until effectively over the past 5 months or so, and then we
mhm.
launched our first game this summer about 3 weeks ago,
Okay.
and you know we also launched another 2D game, which is not sure we can see it on our site today, but we won a hackathon for it, and we've actually launched a fishing game similar to if you I'm not sure it's on our site yet, but we've
Well,
won a
I know
hackathon for it, and it's coming soon.
I know Docs has, a few more games in here like blackjack and lottery and spin the win.
Yep. Those are things that we didn't think were quite appropriate for our mainnet site at the moment, but you can navigate the palace here. That's another thing that we want to encourage, 3D artists to come around. If you click navigate the palace there, it should show you something interesting.
Yeah, I was actually looking at that earlier here. You can jump from room to room. Let's go to the game room because I haven't been in that room yet.
Yep. So it's really just a bunch of rooms. If you go to the main room, that's probably the most interesting one. There is also a balcony room. Those are both
Is that
interesting.
the room 1? Is that the main room?
Yeah, let's try room one.
Yeah, there's some I
There's
think
some
there was
hidden
some
rooms as well.
armor.
Yeah.
Oh, hidden rooms. Oh, now I'm looking a different direction than I was looking before. Is there a way to, like, turn in here?
Uh,
Or is it just which room you come from
Not at the
determines
moment.
which direction? Okay.
Yeah, we're really just trying to get 3D developers interested in us, Unity
Yep.
developers, because we would love actually Unity-based games to come around our ecosystem as well. That's a big part. Is we would love to attract developers to our ecosystem.
Yeah. Yeah, yeah. And is the idea that this is a I mean, I don't wanna say it's like a metaverse thing, but it's,
Yep, a metaverse, Ready Player One
there we
type
go.
aspect. Yeah,
And this is all gonna be navigable at some point. I'm just imagining this is like the biggest gaming complex in the world potentially, right? You go to
yeah, exactly.
Caesar's Palace, for example, and it's very
Yep,
opulent and very interesting. As a matter of fact, I was just in Vegas this last weekend, and just the architecture is crazy. Of course, they're designed to keep you in their building, so they have you twist and turn as much as
exactly. That
possible. But
captive experience
right.
is
But is
huge.
the idea here that we kind of like recreate that experience in like a significantly more opulent way because it's virtual and we're using Unity to develop that experience? And then I'm guessing there are games everywhere that you can play, and the games all maybe have different mechanics, different developers, different user experiences, but kind of they all reside in Satoshi's Palace, and they're all kind of like potential earning games types of things.
Yep.
Is that the
So
vision?
you've hit it more or less on the nose. There's
Okay.
one sort of aspect that I think we're missing is, we want to develop this metaverse land where anything can happen. And one aspect of that would be Satoshi's Palace, where this captive gaming experience, just like you said, you go to Vegas and you enter a nice, beautiful building with beautiful artwork, beautiful architecture, and you
Hmm.
get to go play all sorts of games in there. But in addition, we would love developers of all kinds that, maybe if you want to develop a first person shooter as well, you
Mm.
could come into Stoshi's Palace and develop that, or really any type of game that's in the 3D world. We would love to encourage more 3D developers around us.
Okay, so you're really building like an entire game development community. I mean,
Yep,
this isn't
that's
just
that's the
like
goal here.
this isn't just your team building the technology and recruiting developers from the outside to build games. This is like, hey, you're a game developer, you got a first person shooter, or you've got some type of survival game, resource collection game, RTS, or something like that. come deploy it, and maybe even part of the experience is like, hey, we've got in our main lobby, we've got like our featured game of the week or whatever, and your game is like available to play right in the middle of that room type of thing.
Yep, yeah, a gaming platform for all types of games, all types of developers, and that's how we can really just get this massive developer community that can churn out amazing games on a regular basis that are constantly being updated and constantly making new things. And that's
Mhm.
where we want to get to is lots of developers, lots of new things, and lots of eyes on us.
So is the value proposition here to the game developers that you guys are handling the smart contracts, or is the value proposition that this is more of a like a distribution platform?
Certainly, we want to be as Eventually, this is a DAO structure where
Mhm.
lots of different, we've obviously taken a large starting part of that where we'll try to bring in these initial developers. But once we have enough developers, it becomes a DAO of developers making this amazing 3D and 2D interactive gaming platform.
So is this going to strictly be on web, or are you going to have like a desktop experience or a mobile experience?
Certainly for our 3D aspects,
Mhm.
you can compile Unity to a web environment as well
Mhm.
as to an actual desktop. We'd certainly allow you to use Unity in a desktop sense there. Wallets get a little bit interesting there. We'll need to
Right.
have a wallet integration within a desktop, which is certainly something doable. It's just something new that people probably aren't used to yet.
Well, I know like Immutable X, they got their IMX passport, which is probably the cleanest experience I've had with integrating a wallet into a game. Like I played their Illuvium, the game Illuvium that
Hmm.
uses the IMX passport. And it was just like a normal, like high quality first person shooter slash resource collection slash Pokemon style collecting game, and evolution and arena battle game. Interesting concept how they kind of blended a lot of those things together, but it's cool. But they're using the IMX passport, and it just made it almost seamless to log in. You just log in, kind of like you do with Magic Link, with your email, and it just lets you log in, and it creates kind of a temporary non-custodial wallet type of thing that a lot of them are doing, where you can claim the wallet whenever you want. But by default, getting in and just playing the game, you don't really need to have to understand how to set up or integrate a wallet. So I've seen a
Yeah,
couple projects
yeah,
like that.
I think there's two aspects there that are important to talk about. You know, self sovereignty is something that we as a project are fully embracing and fully want
Mhm.
to support. We don't like things that are custodial wallets because we know that
Yep.
all these exchanges go down and then there's this big problem. You don't have your money for months, maybe you never get it back, who knows. And we want to make sure that anything we develop is going to be self sovereign for our users. But in addition, we need to make sure that, especially for trying to migrate gaming communities from Web 2, they're certainly going to be a bit off put if they have to get
That's right.
set up this whole new wallet and learn all the things that we as Web 3 users know about wallets. And, you know, having to confirm transactions really hurts your gaming experience, and having to write down your seed phrase, in some capacity, you're going to
Mhm.
need a password of some sort. But we've been looking into what we call our super hot wallet, which is a self-sovereign wallet that allows you to log in easily and not have to set up your own wallet. It's a browser-based wallet where your keys will be stored on your computer and your computer alone, and you'll be able to log in with a username and password or with a recovery seed phrase if you have one. And that is what will allow us to go from a Web3 gaming platform to a gaming platform that anyone can come to.
You know, uh, a couple things strike me here. The first one
Mhm.
being that, like, how do we get the web? And this is something that we're challenged with, right? As well, we're having
Yes.
all of these discussions with all of our technology as well. But how do you remove that friction? Our motto in our company is it's kind of like our own Hippocratic oath, where we just say add no friction, as opposed to do no harm.
Yep.
We're like add no friction, and only add value. And so that's our motto as a company, which means that we're addressing probably the one of the biggest friction points in crypto is the key management and key recovery, transaction signing, all that stuff.
Yep.
And the big question everybody's been having for 10 years now is like, how do we do this in the most seamless way? And we've got your Magic Links, we've got your IMX passports. We even have like Fireblocks that uses MPC, their own MPC model for doing it. So we've got a bunch of different protocols that feel okay. But I was playing Yu-Gi-Oh! Master Battle or Master Duel the other day. My
Mhm.
son is huge in the Yu-Gi-Oh! And so he was like, "Hey, I want you to play it." And I'm like, "This is too complex. I'm never going to figure this out." He's like, "Go play Master Duel for a couple hours." And I was like, "Okay, I'll go play Master Duel." That's one of the cool perks of my job. Part of my job right now is playing games and reviewing
Hey,
them.
we'll take that.
Uh, yeah, seriously. Now, Yu-Gi-Oh! And Master Duel is not on my list of games I have to play for work, uh, but I went and played it, and I played it on my PC, and I thought, okay, this is fine. One of the first steps is like, okay, import your data, and I'm thinking, okay, I don't know what that means, but go ahead and start the game because I've never played before. Then I hopped on my phone and I started playing the game, and the first step is import your data, and I'm sitting there thinking, are you telling me I'm going to have a whole nother instance of this game on my phone versus my PC? And I was like,
Mhm.
I wonder if this is just like and I haven't done it yet. I'm really curious. I'm now going to go do it after this conversation, but I'm curious if there's like some long string or file I have to copy over. And I'm thinking, how much different is that from what you just described of, it's in your browser and you kind of use local storage or whatever you're using in
Mhm.
your browser. Maybe local storage is not the secure way to do it.
Yeah, no,
Um,
he certainly wants
I,
to be, browser specific and site specific.
That's right. And so, and I actually hear a lot that like cookies are really the way to go. So anyway, point being is like, I wonder if your credentials would be stored with cookie password protected, kind of encrypted version of your keys stored in a cookie that you could then export from the game and import into another platform that now, I mean, we're not far off from that with Yu-Gi-Oh! Master Duel, right? If I want to
Yeah,
take my collections from one game to the next, I have to like export something here and import it over there. There's no like auto syncing thing that happens in the background like what would happen in most of your online games. So that was something that kind of struck me as odd, but I was just kind of like, oh, okay, maybe some people are actually already more familiar with this mechanism than I'm giving credit for. Because I always think of that being like
that's
a
fair.
uniquely Web3 experience versus the Web2 experience.
Yeah.
So there was that piece, and then also think about it. Like, how many games are using authenticators now? Like, I remember when Blizzard, when the BattleNet introduced the authenticator was something like 15 years ago or whenever it was, and I remember thinking like, there's no way I'm going to use this authenticator. That's an extra step. Now it's like second nature to use authenticators. Everybody uses
True.
authenticators, and it's like, okay, well, we socially we overcame that friction because we demonstrated the immense value of whatever it is that we were doing. And in BattleNet, it was mostly because of World of Warcraft. People would hack your account, take your gear, go
Mhm.
steal your gear, and now you get back online. And you're like, wow, I worked 3 years to get that gear, and it's gone. And people felt that was the value in having that authenticator was like, I'm never going to let that happen to me. I've invested too much time to have all of my gear stolen.
Certainly.
So so I get the
Yeah.
feeling like it's right now we're kind of in a position where the Web 2 audience isn't interested in participating in the Web 3 friction of key management. I think we
Yeah.
can simplify that and make it easier for them to adopt, but I also am not totally against, if we do it well enough, like there may be a transition at some point if we can demonstrate the value. I think that's the key piece is,
Mhm. True.
there has to be a value proposition there that justifies that extra piece of friction.
Yeah. I mean, we were talking about this, me and my friends were talking about this a while back, and we were thinking of how we can just make it either as similar to Web 2 or as seamless as possible in general. And this isn't the perfect solution, but one thing we've thought of, and I'd love to hear your thoughts on this, is we can create a private key from a username password combination.
Mhm.
And that could be a fairly easy user experience that people are used to, where you put in a username, you put in a password, and now you're set up with a private key that you don't actually have to worry about. You never see it, you never interact with it, you never sign transactions, you never actually look at that. It's just handled for you. But there was one problem with this that we were looking at, where people tend to associate username and password with, okay, I could somehow recover this with my email or something.
Mhm.
And that's something that, to be self sovereign, we're struggling to find a way to support or how to make that happen in general. I mean, what do you think about kind of losing your ability to recover, or maybe there's a interesting way we could recover that? I mean, we can have them download their private keys in addition as well, but maybe that's too much friction. What are your thoughts here?
Yeah, well, see, there's the Web3 auth. I don't know if you're familiar with the Web3 auth protocol. It's been around for I think 5 or 6 years. But their whole thing was like, we're going to shard your key into 3 shards, and if you can recover any
Hmm.
of the 2 shards, then you've got your key.
Yep,
And
I've heard of those.
yeah, and so what they would do is they say the first one would be like something stored on a blockchain, and so they had their own blockchain that you would store that one shard on, and by itself it's useless, right? But it's on a
Hmm.
blockchain. Honestly, maybe Secret's a better blockchain to solve this problem.
True, that can make
It'd be
sense.
worth it'd be worth exploring Web3 auth in secret, because that one shard of your key could be stored in an enclave, and all you can do is just, if you hold the key, you can request it. Now the challenge there is, like, if you're trying to recover a key to an account, that is the key you're missing that you would use to query to get that shard.
Hmm.
That could be problematic. I lost the
Yeah, you're
key.
chasing your own tail there.
Exactly. Yeah, you don't have the key that you need to recover the key, the shard that you need. So that's one problem. But maybe there. I'm sure Web3 auth has thought about that. The other shard gets stored on your device, so it's usually
Mhm.
a file or a string in your browser or on your computer, somewhere that's kind of like you're not totally aware that it's there, but it's stored there. And then the third
Mhm.
one is usually like a user provided component, either like a username and password or an OAuth credential or something like that from your socials social login. So they basically sharded the password and said, hey, here's the 3 shards. And maybe the answer there is you have one account that you use for managing all of your other accounts, and that one, hopefully you don't lose the key. And then you can
Mhm.
kind of do Web3 auth for your other accounts. Um, so there might be a way with like Web3 auth to do that in a more meaningful way. I think the two weak points in Web3 auth was like, if you reformat or clear your browser history or whatever, you lose one of the shards permanently. So it's like, okay, well, I only
Oh,
ever have 2 shards. And then it's like, one of them is on a public network and anybody can get that shard. So really all I'm doing is username and password protection. That's all I'm doing anyway. So that was the argument of like why Web3 auth maybe is not as great as it sounds, because one shard is public and the other shard is just your username and password. Might as well just use username and password and call it a day.
yep.
So that was the argument, why that was probably not the best answer. Now, something we're working on, it's something that comes out
Mhm.
of the Hedera ecosystem, is something called decentralized recovery. And the idea is
Interesting.
that you shard your password amongst a number of trusted friends, so among your
Oh,
network of
this
friends.
is social recovery. I've
It it's
worked a little
similar.
bit with that.
Yeah,
Mhm.
well, social recovery is a little bit older. Decentralized
Mhm.
recovery is kind of a newer take on it, in that
Interesting.
you're basically checking that your peers are available frequently enough that if anybody becomes unavailable, you can reshard and redistribute to the other peers in your network. And as long as
Okay.
everybody has that piece of software online and they're able to talk to each other, say once every 5 minutes or once every 10 minutes, you never have to have key recovery. You generate your key on your device. You have your network of friends. You select who your trusted friends are, and boom, now your keys are secure, and it rebalances your shards for you every 5 or 10 minutes. So you always know that you're going to have enough shards out there that you can recover. Now, the weak point of this is, what happens if you don't have network for an hour on end? Maybe you're in the air or you're in
Yeah.
a region you don't have internet. Like, that becomes a challenge in itself. But let's say the vast majority of people have internet all day long,
Yeah.
every day. So
At least
um,
most of your friends should probably keep their internet up, assuming they don't
that's
all live in the same city.
that's right. Yeah. Well, and the cool thing is like, so gaming's the perfect use case for this, because in gaming we already have clans and tribes and
Oh, yeah.
guilds, right? We've already got our trusted friends, if you will. And how cool would it be to say, like, hey, you can earn money in this game. Just choose 5 friends or 10 friends from your guild or clan that you trust. And even what I mean by trust is, like, they're not going to extract your shard and
Yeah.
collude and share it with other
That is
people.
a
Right.
yeah, that is a attack vector here is your friends weren't as trustworthy as you thought.
That's right. Well, and that's why it's good to have, with decentralized recovery, the idea is that you've got a broader group of friends that maybe don't even know each other type of scenario. I know if you're in
Yep.
a guild, you all kind of know each other. So
Yeah.
at least from a virtual perspective. But if you have multiple games going on and you got different guilds and you choose two people from each guild that don't know each other, or you've got your family and friends outside of your gaming community that are also part of this population from which you select your sharding sample.
Mm, yeah.
You can kind of
Certainly needs
add
to be a
security
yeah.
by distributing it.
Yeah. There needs to be some sophisticated process for being like, okay, these people at least don't know each other, so there's no way they're gonna
That's right.
collude, hopefully.
Yeah, and there may be a way to, like, in the system, discover that, right? So if we have our own network, say we're on a blockchain, we can tell who's transacted with each other. We can
True.
tell who shared shards with each other. We can build a map and say, all right, of your network, if you're to choose these 5 people, they're the least connected to each other type of
That
scenario.
makes sense, yeah.
So, I think that there are some ways to enhance that and make it more secure. It's a lot more algorithms, a lot more compute, but I think if you figure it out, you eliminate that friction of key
Yeah,
management
and that's really
altogether.
what's just super important here is making sure that, 1, the user can recover, and 2, they don't have to worry about it.
Yeah.
That's huge.
Yeah, and it's a nascent technology. Like, they just recently, I think at the beginning of the year, published the what they call the DREC Alliance, and it
Mm,
has Hedera and Algorand and a few other companies in there that are all participating in this thing. So it's a very new protocol. I think the proof of concept came out last year, but it's something that we're exploring as a team and going, okay, how can we just make this better? How can we make this production ready? And how do we
yeah.
make it resilient and reliable? And that's actually part of our deep in strategy. So I don't know if you know much about Tashi, other than the maybe some of the hearings you've heard from some of our team members.
Heard a little
Um,
bit, but maybe you can give me the rundown.
yeah. So at the highest level, Tashi is a peer-to-peer gaming network, and that's really what we're supporting. And our whole goal
Mhm,
from the beginning, we started out in the gaming space, and our objective was, how do we take Web3 technology and enhance Web2 gaming? And by enhance, we mean, can we make it more convenient? Can we improve the gamer experience? Can we reduce cheating? Can we reduce the cost to the game developers and studios?
mhm.
Like, we're looking for real value points here, right? We're not adding, like, a lot of people will take convenience over security. So it's hard to convince people that security is important. And a lot of people take convenience over sovereignty. So,
True.
and that's the vast majority
I
of
think
our
it's
audience.
unfortunate, but it is.
It is unfortunate, but what if you can give sovereignty and security while also giving convenience? And that was kind of our vision, is
Yep.
like, how do we take the best of the Web3 technology across all the platforms and inject it, optimize it, first of all, make it better, and then inject it into the Web2 gaming experience, so that now they've got the same convenient gaming experience, but with the enhanced security and sovereignty. And there were a bunch of pieces of that. And the first piece was the consensus algorithm, which is kind of the heart of our protocol. We basically wrote our own consensus algorithm, our own peer-to-peer DAG-based consensus algorithm. And when I
Mhm.
say DAG, that's just the structure. There's an algorithm that lies on top of the DAG. The
Gotcha.
DAG is just the data structure itself, but it's incredibly efficient, incredibly fast. We've made a ton of improvements on it since we started it. But our first proof of concept was, can we make a horse racing game where the first person to press the space bar 100 times is the winner? And we just made it strictly peer to peer. So you can think
Mhm.
of, like, gaming right now as server client or host client uh,
Yep.
architecture. There really isn't a peer to peer protocol out there. There's a protocol called Photon, which has a relay that sits in between that ensures it becomes the authoritative
Mhm.
order of transactions. So you can think of it as being like a Kafka uh, cluster, right? It's just a message
Gotcha.
queue. It's a fancy message queue. And its whole job is just to relay messages from everybody, and whatever order it comes out of the message queue is the order everybody executes on. The difference is how do you calculate order? And with Photon's relay, the relay calculates order. So there's an authoritative component to their relay. It also potentially adds latency, because now you have to talk through a relay if you want that functionality. And if you want to add the additional layer of trust, it actually becomes what they call a referee, which is like a more involved relay in your game logic. And so now
Mhm.
you're basically talking server client. It's just a light server.
So, what have y'all done? So, are y'all using this, or have y'all
Yeah.
made something happen with the DAG too? What's the structure here?
Well, so we're not using Photon at all. We look at Photon as kind of our competitor. Um,
Gotcha.
so we built a consensus algorithm that says that all the peers can connect to each other. Every peer just blasts their game events as quickly as possible. And then every peer calculates the state of the game independently. But because of the algorithm, they're guaranteed to calculate the same state. So it's you can think of every
Interesting.
player as being their own game host, and the hosts or the servers are synchronizing with each other in the background. So they're
Gotcha.
synchronizing on the order of events of the game between each other.
So
So
here's my question. How do you stop the cheaters?
which cheaters? Because we got a whole bunch of
So
different
let's say,
mechanisms for mitigating cheaters.
I mean, let's say we're playing CS:GO,
Hmm.
and we have a decentralized network of players playing CS:GO.
Hmm.
And I say that I shot first. You tell me that you shot, and I said no, I shot first, and even though I didn't even shoot.
So this is where deterministic lockstep comes in. Deterministic lockstep is a game development pattern that's very mature and very well understood, and has something called
Gotcha.
predictive rollback as well. But the idea with deterministic lockstep is that everybody's subscribing to a stream of events.
Hmm.
The magic of what we do is that everybody's broadcasting their moves, their game events, not necessarily state changes. There are ways you can do state change as well, but you're just saying like, I pulled the trigger at this timestamp, right? Now, the
Okay.
first person to witness that is going to say, I saw your trigger pull. Your timestamp is after the last broadcasted or finalized transaction and before my timestamp, right? So they go, okay, so we have
Okay.
a timing validation that happens between the peers, first of all. Um, but in order to reach consensus, 2/3 of the players have to witness that emitted game event. So if I say I pulled trigger at this timestamp and I'm pointed in this direction, this is my vector, right? Um, your Everybody's going to witness what direction you're pointing, and when you pull the
Hmm.
trigger, they know what round you're firing, what type of round you're firing. They know all of the physics that apply to trajectory. Everybody's going to calculate all that independently. So the first thing they're going to calculate is the order of game inputs. They're going to say, you pull the trigger or I move to the left. Which one happened first? And it's
Hmm.
going to count in ticks. And it's going to take all of these events. It's going to take your event of pressing A for strafing, and it's going to take
Sure.
my event, or maybe it's Q for strafing, whichever game you're playing.
Yeah.
But you strafe, right? Did you strafe first or did I pull the trigger first, right? That's the question that we have. So what happens is everybody's streaming these events to each other. They're broadcasting them to each other. The algorithm calculates the order of events, and then it calculates how many ticks are in between each event based off of how quickly all those things happen. So we're not using time per se to
Hmm.
calculate the order of events. We're using ticks. And by using ticks, we can say something like, okay, you pulled the trigger from that far away. Based off of our physics engine, that would take 3 ticks to hit the next person or 1 tick to hit the next person,
Gotcha.
right? Did you press your A button within 2 ticks or outside of 2 ticks? If you press it within 2 ticks, you dodge the bullet. If you press it outside of 2 ticks, you got hit. So the algorithm actually handles a lot of that net code for you because of the ordering. It's just math to us, right?
That's nice. That sounds like a complex algorithm. But so I
It's a
mean,
very complex algorithm that took us
yeah,
almost 2 years to get to the point where it is right now.
I bet the way you describe it sounds quite complex. So let me see if I get this straight. It sounds like we have, let's say there's 5 people in a game,
Mhm.
and they're all broadcasting messages to each other at different based on their actions, and everyone's trying to reconcile what the order is of each transaction as it comes to them.
That's right.
And so, with some degree of certainty, assuming that all of your friends or some amount of your friends um, aren't colluding to try to pull one over on you, you
Right.
can probably say that yes, this is the order of events, assuming 4 out of 5 didn't collude or 3 out of 5, whatever the number is.
Yeah, so it's you have to have 2/3 of the player base,
Mhm.
agreeing to calculate consensus, or you should say I should say being honest. You have to have 2/3 being honest.
Mhm.
It can be up to 1/3 can be dishonest or faulty, right? So those are the 2 kind of scenarios that happen. But as
So
long
is
as
faulty,
2/3
is that
agree.
malicious?
Well, it could be malicious or malfunctioning. It could be either one.
Okay.
So it just means that less, because we don't know yet. Now, if you consistently are calculating the wrong state hash, then we're applying a
Yeah,
reputation system as well that will
that makes sense.
affect you. So, um, but as long as you have 2/3 of the players agreeing on the state, on what's happening, the order of transactions in the final state, because they're going to pass around state hashes periodically to say, are we still in sync, guys? Because this is why it's important not to use delta time, which, by the way, is going to be the hardest challenge to overcome uh, in gaming, especially in Unity. Everybody uses delta time all the time, or time delta, I think is what they call it.
Yeah,
But that's grabbing your local time from your machine and then calculating the deltas based off of the passage of said
gotcha. And
time.
everyone might not be on the same clock.
Exactly, or they might not have this. There might be some weirdness in clock cycles, the timing of clock cycles, and so
Yep.
that's why we use ticks instead of using local time, because then we can just say whatever the consensus tick count is. So the consensus is creating its own decentralized monotonic clock. That's basically what we're doing. Is we're saying these events happened at these different points in time in this
Mhm.
particular order, and no events ever happen at the same time. They always happen one after another. So we've got a sequence of events, and you can almost think of it like as a super smart message queue. Everybody's blasting their events, and the
Mhm.
outcome is a single stream of events that are all in a specific calculated order based off of how everybody is reaching consensus with each other. And they all have a position in that sequence that you can now run game logic calculations on. So it simplifies the netcode significantly, because one of the hardest things to deal with in netcode is, okay, what if people's clocks are off? How do we reconcile that? Or what if the person's latency is high enough that
Right.
had that latency not been there, they would have actually dodged that bullet, right? And so a lot of games try to give preference to high latency players because they want the high latency players to have a good experience, right? And so that's where a lot of times in Call of Duty all the time, you're like, I have video of my crosshairs on the person and shooting the bullet, and the person didn't get hit, and it's like, what the heck? But that's netcode. That's what netcode does.
Mhm.
And what we're doing is we're taking netcode off the table. We don't have to have developers think about how to handle latency, because it doesn't really matter what your latency is. If you have high latency, you just may not participate in consensus. But as soon as your message reaches 2/3 of the network and they calculate your position, you have just as much of a chance of getting in that stream as anybody else, because it still has to traverse 2/3 of the network. Now, the challenge is
Especially
that first
because
hop.
the latency could be different from peer to peer. Because like if I'm talking to 5 people in a CS:GO game, I'm gonna get 5 different or 4 different latencies.
That's right. Yeah, and you can think of this the algorithm is kind of smoothing that out. So really the important thing is like, what is the fastest 2/3 of the network? Those are the ones that are generally going to participate in consensus. Now that might be different based off of what are the fastest 2/3 of the network relative to you,
Mhm.
because your first hop might be really fast to the next person, but it might be really slow to the next random player that you're talking to, right?
Yeah.
So there is that question. But the cool thing about it is, because there's a 2/3 requirement, it smooths out the latency differences. So you can have vastly different latencies with very similar and fair gameplay. And so you have to handle netcode a lot less. But this also means that we like immediately inoculate things like lag griefing. People that switch on and off latency to rubber band around the game or whatever. And we're like, cool, if you switch on your latency super high, all you're doing is delaying your inputs, but it doesn't change your location. Like, everybody's still going to calculate. If you're like, I'm going to lag switch while I'm strafing, it's going to be like, oh, that person strafed one position to the left instead of 20 as you would in old netcode handling.
Gotcha. So
Because
every peer is gonna, validate that what you're doing was, a valid action
right.
and not
Yeah.
just v clipping somewhere or something.
Yeah, and that's deterministic lockstep, right? In deterministic lockstep, you do the exact same thing where you receive a stream of inputs and you calculate
Mhm.
the state deltas. How does the state change? And in predictive rollback, which is kind of the second part to deterministic lockstep, it's like, okay, as I'm pressing buttons on my computer, I'm going to go ahead and move my character immediately whatever direction they're supposed to move. And then when the
Mhm.
deterministic lockstep happens and I get the stream back, if there's a difference between what's happening locally and what happened
Mhm.
in the final stream, you just roll it back a couple
Gotcha.
frames,
So you
right?
optimistically move your character in before the game state is consensus.
but you see that sometimes in video games anyway right now. In
Oh
Web
yeah,
3
yeah,
and
yeah,
Web
yeah.
2 games, you get that where you're running, but because you've got latency, you kind of like jump back every once in a while, jump back a little bit, and then you keep going. You're like,
Yep,
oh
yep.
dang, my lag is super high right now, and then you're like, I'm going to get out of that
Yeah,
game and
no, that's
jump
a
into another
very,
one.
very common video game optimization is just being optimistic about what you and the server
That's
are
right.
gonna say.
Yeah, and most of the time, if you write your optimistic rollback correctly, or smoothly, I should say, like the players aren't ever going to notice it. It's going to be
Oh
really
yeah,
rare that they notice it.
yeah. Like,
So
unless they're lagging horribly, that's a
that's right.
non-issue
If their
usually.
latency is super high, that could be
Yeah.
problematic. But even for us, if people decide to use uh, uh, the predictive rollback, because one alternative is you don't do predictive rollback. You just say, I pressed an input and don't change my UI until the input has reached consensus and come back to me as a deterministic log steps final step, right? So that's one approach. It's just I don't want to
Mhm.
see my character move on my screen until everybody's witnessed it and I have a timestamp. And that's one way to do it. And it works. It actually is probably the most guaranteed way to keep everybody deterministically in sync. But then sometimes, especially if you have some latency, it's going to suck when you press a button and your character doesn't move for 500 milliseconds, right? That kind of
Yeah,
sucks.
you want that instant feedback of,
Right.
your what action you did.
And that's why I think that's why that predictive rollback is a good feature to add to that deterministic lockstep paradigm. But our goal is to keep the consensus latency low. So if we can keep consensus latency below,
Mhm.
30, 40 milliseconds, I was playing a game. What was I playing? It was a shooter game. It was an FPS. I think it might have been Call of Duty. I can't remember if it was Apex or Call of Duty. But I had the group that I had jumped into had 120 ping or something like that. I had 120 ping, and I'm sitting there thinking like, game's still playing pretty smoothly. So, we have a little bit of headroom. We try to keep that around 40
Mhm.
milliseconds on the ping,
Yeah.
but sometimes you get up there depending on how the groups are formed and where you can find games. Actually, it was Call of
Yeah,
Duty. Yeah, it
especially if
was
you're
Call.
going for, like, a global community, you can
Right.
be connected with someone halfway across the world.
That's right. That's right. So for real time games, we're keeping the consensus component of that latency as low as possible. 30 to 50 milliseconds is really our sweet spot for, 4 to 64 players. That's kind of where we've tested at.
Yeah, I
That's
mean,
really where
that's basically like client server at that point in terms of speed. It's hard to hope for
that's
much
right.
better than 40 milliseconds.
That's right. Yeah. So that's been our goal. So that's the technology we've built. Now to make that reliable and to make that available, we almost need DPIN. And we're thinking of DPIN as like, how do we take all of these
Mhm.
cloud-based gaming services, like matchmaking, like
Yep.
leaderboards, even relays, proxy relays, or failover nodes. Like, how do we take all that stuff that would normally be like a Web 2 cloud service and move that into a DPIN structure, a DPIN architecture? And so that's what we've done is we have the what we call the Tashi sessions, which is that kind of side chain, the ephemeral side chain that is Tashi's consensus algorithm for peer-to-peer gaming. And then we've augmented it with this DPIN layer that ensures that we've got failover nodes. So if for whatever
Mhm.
reason you have 5 players over here and 2 people fall out, consensus is at risk, right? If
Yeah.
one more person falls out, consensus freezes. So we're like, okay, go to our DPIN layer and grab somebody to fill in and just be consensus. They're not a player, they're just there to facilitate consensus, some random person from the DPIN resource pool. And so we have failover nodes that will hop in and ensure that consensus can continue to happen.
That's
Also,
smart. Yeah.
not everybody's going to be able to see each other. If you're in Starbucks playing a game, your IP address isn't public. So we need a proxy. So our DPIN layer, we have what are called proxy relays, and their whole responsibility is to have a public IP with low latency relative to you that they can now just like send their transactions to and just throw them off into the wild to the other players in the game. So now you have like almost like a VPN layer, if you
Yeah.
will. But our goal, as opposed to being VPN where like you can go overseas, it's like how can we get you with the lowest latency with your
Mhm.
proxy relay? And
That's
they're just a
that's really
dumb relay.
interesting. Y'all have a lot of interesting tech going on. I'm interested, like, what y'all's business model is. So you're trying to offer the platform to make games on, it sounds like? Where do you monetize?
That's right. Yeah. So we're giving away the consensus component of it. We want people just to use that because we want that in as many multiplayer games as possible. We even have like a bridging technology that allows you to move assets between L1s, twos, and threes. and the gaming sessions, and that we're going to give away. The D pin's where we make all our money. So there's
Gotcha.
transaction fees on the D pin. There's treasury. There's speculation on the Tashi token at some point. We're going to do a node sale here pretty soon. So lots of things going on, but we're going to give away as much as we can because we want this technology to get out there, and we'll figure out the business part where people need it.
Yep, I like that strategy. Just get it out there, get the community around it, and worry about the money later.
That's right. Absolutely. So, well, hey, we are at the hour. Twitter's already shut off our stream because that's what X does. But we're still going on YouTube and LinkedIn. But I want to thank you so much, Kenny, for joining me today. Super interesting. I'm really excited to see what you guys do with Satoshi's Palace. I think there might even be some synergies between us. So we might have to have
Yeah,
further
we should definitely keep in
discussions.
contact. I love talking to you, man. You know all the interesting computer science topics, and it's fun to talk tech with you.
Yeah, absolutely. Well, and we don't have to do it on stream, although on stream is very valuable, and I would appreciate it because then we can create content as well. And I'd love for you to have your camera on next time with your privacy face on, because that would be cool too.
I'll get that going again. Well,
Yeah, I mean,
yeah,
when
the next
let's
time.
plan it out next time, right? Not
Yeah,
a last minute thing. So awesome. Well,
gotcha.
thanks again for joining us. And then everybody, as you know, every Tuesday at noon Pacific, we have this stream. Join me. Make sure you subscribe on YouTube, LinkedIn, or X. If you're doing it on X, make sure that you set your alarm so that you know when we're going live. Otherwise, you're welcome to watch it after the streaming has been done. YouTube is the easiest one for us to get involved with. So also, if you ever want to interact with us on the live stream, YouTube is the best place because when you put your comments into the YouTube live discussions, I can see it right here in our streaming platform, and we can interact with you, call you out on live stream. So thank you again for joining us another week. We'll see you again next week. Cheers.